All right, welcome. Tonight we are pulling back that big velvet curtain because behind every single dazzling Broadway show, every perfect entrance, every show-stopping finale, there's a hidden script. And no, it's not about lines or music, it's all about logic. We're going to uncover the secret math that can actually guarantee a flawless opening night.
So, here's the big question, right? How can a producer who's surrounded by what feels like total chaos create absolute, rock-solid certainty? Well, the secret isn't just hoping for the best, it's logic. And forget that boring stuff you might remember from school. Think of this as a producer's secret weapon, a tool for turning maybe into definitely.
And scene. Our show begins with Act 1, the casting call. Before a single actor learns a line, we've got our first big puzzle to solve, the costumes. We need to make sure the cast looks amazing, of course, but what's really interesting is how we can guarantee with just a few colors that some actors are bound to match.
This brings us to this fantastic, super simple, but really powerful idea called the pigeonhole principle. It sounds a little goofy, I know, but the logic is just perfect. Imagine you have 10 pigeons, but only 9 little pigeonholes for them to fly into. What has to happen? Well, at least one of those holes is going to have to house more than one pigeon. It's a guarantee. There's no other way.
Okay, so let's translate that from farm animals to show business. In our theater, the actors, they're the pigeons, and the different costume colors we have available, those are the pigeonholes. See where this is going? By looking at it this way, we can start to make some seriously solid predictions.
So here's the problem for our producer. We've got 4 costume colors to play with: red, blue, green, and yellow. The question is, how many actors do we need to hire to be 100% certain that at least 2 of them will be wearing the exact same color? We're not talking about probability here, we're talking about a lock, a guarantee. What do you think?
The answer is 5. Just 5. So why? Well, think about it. Imagine the worst case luck. The first actor grabs a red costume, the second blue, the third green, the fourth yellow. Okay, so all 4 of our pigeonholes are filled with 1 pigeon each. But what happens when that 5th actor walks in? There are no unique colors left. They have to double up. It's a mathematical certainty.
Okay, let's raise the stakes for Act 2. We're moving from just a handful of actors to the entire cast and crew. A really sharp producer could walk into a full rehearsal and make a bet that sounds completely impossible, but is actually just pure, simple logic. So here's the bet. Picture it. The producer stands in front of all 400 people working on the show and says, "Folks, I will guarantee with absolute certainty that at least 2 of you in this room share a birthday." Now that sounds like a wild claim, doesn't it? Would you bet against them?
Let's use our pigeonhole principle again. The 400 people and the cast and crew, they're our pigeons. And the possible birthdays? Well, there are 365 days in a year, plus 1 for a leap day, so that's 366 pigeonholes. We have way more people than we have days. You can see it now, can't you? There just aren't enough unique birthdays to go around.
And it's a beautiful example of how powerful this is. We don't have to ask a single person for their birthday. We don't need a spreadsheet. We know, just based on the numbers, that a shared birthday is an absolute lock. It completely takes luck out of the picture. So yeah, definitely do not take that bet.
Now on to Act 3. You know, every big show has that last-minute, heart-stopping crisis. So imagine this. Total blackout in the wardrobe room, seconds before the big tap number. We have to grab a matching pair of shoes right now, in the dark. How on earth can logic save us here?
The tool we need is a brilliant little mental model called worst-case luck. It's kind of backward, but it's amazing. To guarantee you'll get what you want, you don't hope for the best. You plan for the absolute worst. You literally imagine the longest, most unlucky streak possible. Because the very next thing you do after all that bad luck has run out, well, that has to be your success.
Okay, so here's our crisis. 1 giant box. Inside, 10 left tap shoes and 10 right tap shoes, all jumbled up. It is pitch black. You cannot see a thing. How many single shoes do you have to pull out of that box to be totally, completely, 100% sure you have a matching left and right pair?
Let's use our worst-case luck. So what is the absolute unluckiest you could possibly be? You reach in, you pull out a shoe, it's a left. You pull out another, it's also a left. The absolute worst luck in the world would be pulling out all 10 left-footed shoes one after another. So now you're standing there holding 10 shoes and you still don't have a pair. But wait, what's left in the box? Only right shoes. So the very next shoe you grab, the 11th one, has to be a right shoe. And boom,
guarantee pair.
So there it is. The magic number is 11. By grabbing 11 shoes, you have literally outsmarted the worst luck imaginable, and you've guaranteed your success. The tap number is saved. The show goes on.
All right, time for the grand finale. Welcome to Act 4, the Spotlight Problem. This is what we call the boss fight. It's a much more complex challenge, a technical one, and it's going to require a more advanced tool from our kit, a specific formula to nail our guarantee.
So up until now, we've only needed to guarantee, one extra item in a category. But what if we need to guarantee a whole group of them? For that, we need what's called the multi-pigeon formula. Now, it looks a little mathy, I know, but it's really just our worst-case luck idea turned into a recipe. You take your goal, subtract 1, multiply that by your number of categories, and then you add one more to seal the deal.
So here's our final challenge. The lighting director needs 5 stage lights of the exact same color for the big, dramatic final scene. An intern gets sent to a massive crate that's just filled with hundreds of red, blue, and green bulbs all mixed together. How many bulbs do they have to pull out to be absolutely certain they have 5 of a single color?
Okay, let's just use the formula. It's not as scary as it looks. We just need to plug in the numbers from our problem. So our goal is 5 lights of one color. And the number of holes, which is our categories, is the 3 available colors, red, blue, and green. Easy enough. Now we can do the calculation.
And here's how it plays out. Our goal, 5, minus 1 is 4. Now we multiply that by the number of holes, which is 3. 4 times 3 is 12. Finally, we add that crucial little plus 1, which gives us 13. See, the worst-case luck would be pulling 4 red, 4 blue, and 4 green. That's 12 lights. That 13th light you grab has to give you 5 of something. The boss fight is won.
And with that, our production is a guaranteed smash hit. So, as our cast takes their final bow, let's do a quick curtain call for the powerful logical tools we've packed into our backstage toolkit tonight.
We started with the super simple pigeonhole principle to guarantee a match. We scaled that up to the birthday guarantee. Then, we used the clever idea of worst-case luck to solve a crisis in total darkness. And finally, we used the multi-pigeon formula to handle the big, complex guarantees. These aren't just little math tricks. They're powerful ways of thinking that can create certainty out of chaos.
So I think the real takeaway here is this. Logic isn't some cold, abstract thing. It's actually the ultimate form of stagecraft. It's the invisible scaffolding holding the entire production together, turning the panic of opening night into the beautiful certainty of a show that just works.
And that leaves us with one final thought for you to take with you. Whether it's at your job, in your personal projects, or even just planning your week, what could you absolutely guarantee if you just took a minute to figure out the logical script behind it all? Thanks for joining us.